Yeah. So, very good morning once again, everyone. And the person sitting here in front of you is Dr. Zafar Ahmed. Sir is associated with Indian Mathematics Olympiad program since a very long time. Sir has been a mathematical physicist who has worked on quantum physics in nuclear physics division of BARC till 2021. He hails from 27th batch of training school BARC. In the year 2002, Dr. Zafar Ahmed published an integral in American Mathematical Monthly, and the integral is well known as Ahmed's integral. You can search on Google also. And this integral is given in many encyclopedias, journals, and websites. Dr. Ahmed has been a resource person in various mathematical olympiads, including the JSO MO orientation program, since a very long time. In the year 2009, he took Team India to the Golden Jubilee year of International Mathematical Olympiad in Germany. Dr. Zafar Ahmed has been awarded the degree of Doctor of Science in 2009 by Mumbai University, and presently Dr. Zafar Ahmed delivers enrichment lectures for IIT JEE Mathematics, and also serves as a mentor of conducting this program, Junior Science and Mathematics Olympiad Orientation Program. This program, and before this, many programs Sir has guided and successfully we could conduct because of Sir's guidance. So let's clap loudly for Dr. Zafar Ahmed. Yes, over to you.
So here students are from class 8,
No, 9th and 10th.
9th and 10th. I was told that they were the program to include class 8 students also. Okay. So we are here to discuss some good mathematics. The interesting thing about you people is that to bother about Olympiad mathematics, that most of the students everywhere in the world they find mathematics it is difficult. Okay? And they struggle with it. But there are some students who understand it quickly and start practicing it, and howsoever busy they practice very difficult problems, international problems, Olympiad problems. And others they keep complaining, oh, time, there's no time, I'm very busy, this and that. So you are the ones who like mathematics and problem solving. Correct? So, in the country for over 70 years or so, IIT JEE has been raising the standards of physics, chemistry, and mathematics in the country. Had IIT JEE not been there, our standards in these subjects would have been very poor. But they are now they are as good as anywhere. And that is one reason why a lot of CEOs of a lot of multinational companies are Indians. Most of them they are IITs. But this Olympiad has risen the standards further up. So they have become terribly good. Okay? So I was wondering what I should do here. First I should tell you set up rules or start with a problem. So what should I do?
Second.
Start with the problem. Oh, that's a good mistake. Okay, just find out the roots of this equation. All roots of this equation. And in these Olympiads, these classes don't matter whether you're class 8, 9, 10, 11, or 12. There are some basic things. So the syllabus of this Olympiads is very small, less, but the degree of difficulty is very high. Yeah. No, you just solve this problem. Find all values of x and x, or find all values of x, all roots of this equation. And this class is up to 10:45. So the idea is to find all roots of this equation. If you're done with this, the next question is there.
So that is 4 into minus 1.
4x minus 1. But first you do this. Yeah, so what are the roots of first question? 2 and
0.
0. So it has 2 roots. Okay. Now, be careful. This mathematics is different from what generally we discuss. For example, in your textbooks, 9th, 10th, 11th, 12th books, the board exam books, you will be asked problem. If there are problems to solve them, go and see the answer. Yes, his answer is this. Yeah? Yeah. Speak up. No, what? Don't talk. Give your answer. So, yeah. Now you have to be careful. You have to be careful. So that is what I want to discuss with you. That you be careful. Don't do and keep back the example. Now one of you says that 2 is not a root.
Yes, sir, 2 is not.
Correct? Very good. So what after finding you should yourself check whether it satisfies your equation. Correct? So 2 doesn't satisfy. Very good. What's the name? Manu Maikuta. Yeah. Be careful. This is your job and duty to check whether the group you have got satisfies the equation or not. Because you should yourself be satisfied, then you give it to the examiner. Now the question is why the hell this root 2 has come? And this question is from a very serious book which is written by 4 authors. And they want to show, they wanted to give an example that how an equation can have double root or triple root. Correct? So, but as they said, 2 is a double root or triple root. In your analysis, what it comes out. Double root means this. If in the end you get this is double root. In the end, if you get this, it is a triple root. So whether it is double root or triple root? Double. So they wanted to give an example of equation having double root. But, and according to them, 2 is a double root. And 2 is not a root. So what I'm saying, be careful, even very learned people who have not somehow not followed about IIT mathematics and Olympic mathematics. And they have become scientists, teachers, professors. Even they get surprises. And when they get surprises, they argue. Oh, what is this? Why this 2 is not a root? See this. And then these complaints come to me on phone or actual meetings. Then I tell them, oh, I see. I was not told this. We were not taught this. I was also not taught. The difference is I was interested in IT maths. And because of that, I was interested in what? Olympiad mathematics. Okay? So let's see what. So there is a rule in mathematics that if you want to square both the sides of the equation, both the sides should be positive. If not, then you declare. So what happens here? This is positive definite. So real quantities are of two types: positive definite, negative definite. Positive quantities are always positive. Positive definite, positive definite and negative definite. Negative definite quantities are always negative. But there are indefinite quantities. Sometimes they are positive, sometimes they are negative. So 1 minus x is what? Definite or indefinite? Indefinite. So you want to square, and you want to square it into your fractional x. So if you want to square, you declare, correct? So declaration says what? X should be less than. Now you do your ordinary algebra, and you will get x equal to 0 and 2. 2 will be cancelled because it doesn't need this condition. So what is the root? 0. So it will be very embarrassing if you get root where there is no root. If you get more number of roots where there are less number of roots, and then what? So one carefulness is checked. But this is called theory. So what is the theory? What I want to tell you? If you want to square both sides of an equation, any equation, you can do so if they are positive definite. If not, this is indefinite. You declare. You declare this, and when you get your answer somewhere here, you come back to this. So 2 will be ruled out. And this question in the book is given as a question of double root. Yeah. Pardon? Are there no solutions to that? We'll see. Yeah, hold on. Don't talk to each other. You have enough time to talk to each other and think about various things. Now you just concentrate. Because I won't be there with you later. You just speak to me, tell me your answer or objection or question, whatever. Don't discuss among yourselves. Okay? So this. So this. So analysis is okay, analysis is ordinary, but rules are very important. What is the rule? The rule is when you square both the sides of an equation or any equation, both sides should be positive. If not, you declare and take care of the declaration when you have done your analysis. Now this, how many roots you get? One. What is it? Five. Yeah. Hello. What is your name? Ishan. Where are you coming from? Which school? Where are you from? Okay, so good. These are no solution. Okay, no solution. It is not this thing that we say no solution, so no solution. Or it is also 5 by 4 doesn't satisfy this. But the problem, why the hell this is not a solution? You have not declared things. So let us see. So you declare here. One more thing. Generally, we are interested in real numbers. So whatever comes in the square root, we declare in positive. This and this and this. Correct? So these are the declaration. Now it's square this. So this is positive. So this will be what? X plus 1, x plus x minus 1 minus 2. And this 4x minus 1. Correct? So what is it? This will be, you can say this 2x minus 2x. This cancel. So plus 1. Correct? You write it like this. Now we want to square it. We want to rationalize. We want to make progress. This is indefinite. declare this. To declare this, what 1 minus 2x should be positive, correct? So this means what? X should be less. Now you do your simple analysis which you know. And you will get x equal to 5 by 4. Come back to this declaration. It doesn't satisfy you. No. Yeah. It's very embarrassing, it's very shocking. So all these things can be managed. This was okay. X is greater than minus 1. Yeah, these declarations are okay. How? See this. So it says x is greater than 1, and x is greater than minus 1, and x is greater than 1 by 4. So when you put them on real line, there is an overlap. Sometimes these declarations themselves will be contradicting. So that is why you proceeded. You wanted to square it, but you cannot square, and you square it, it's okay. They are all positive. But then here when you square this, okay? So no, now I'm going to tell you a problem. A geometrical problem. So the question is this.
This question root is 1 by 4. 1 by 4.
Pardon?
1 by 4.
No. This declaration, there are stages. This declaration is okay, so proceed. Sometimes you will find that no overlap here. Don't proceed. Don't waste your time. And okay, so this is okay. This was okay, but here square both sides and declare this. What you have declared this. And then final answer is x equal to 5 by 4. And if any declaration is not met, you don't have that solution is wrong. And you can check, you can actually put 5 by 4. But the point is, you should know why it is not a root 5 by 4. Right? Okay, so this question is there. It says that this thing is 6, and there is a point here, this is 2 units below, this is 4. And this question says that between these two parallel lines, there is a equilateral triangle. So find out the side of that equilateral triangle. So suppose we do this. This is x, this is x, this is x. Maybe for drawing is not very good. Maybe it is okay, it will go through. So how many of you think it will go through geometrically? It's okay. Means by drawing this, can we have an equilateral triangle? Yeah, so some problems can be discarded, or some don't proceed on a problem. You may have a sense that geometrically it not go through or something. I don't know. Okay. Do the thing about it, you can tell me in between also. Is it possible to have a equilateral triangle like this? Okay, so now we come to algebra. So let us see this. So this will be what? This length will be x square minus 4. This length will be what? X square minus 36. And this length will be what? By Pythagoras theorem, this will be x square minus 16. This is right. So what we will do, we will say x square minus 16 is equal to x square minus 4 is equal plus, correct? Then what we can say? We can say maybe x square minus 4 is t. So this will be what? T minus 12, and this will be t, and this will be what? T minus 32. Correct? So we have introduced t, if possible, if you introduce, yeah, a variable t. What? Yeah, tell me, I have two mistakes. So this will be. So this should be what? X square minus 4. Is correct or not?
Sir, x square minus 4 is equal to
Yeah.
Right side. Right. Sir, please.
Okay, this side is okay. Okay, there's one of you tell me what? Well, yeah, sorry, go. Oh, yeah. Yeah, thank you. Okay. Is this okay? Now, first thing you should think geometrically is it possible. Now it can be converted to algebra. Algebraically, whether this equation will have any root. So you can declare. You can declare what t is greater than 12 and what t is greater than 0, t is greater than. Okay. So if is anybody here who thinks that this equation will not have any root? And why? So you should have these ideas. Don't do happy-packy algebra. Just think what equation you have. So what will happen is t has to be positive because they have to be real. This equation cannot have roots. Why? Just without looking into detail. Because this is the biggest quantity. How can a small quantity be equal to biggest quantity plus something more? Not possible. Not possible. Don't do it. Okay? But in websites and all, those who are teaching varieties, they don't see this. And this is the very spirit of IIT. In the country, IIT only raise these points. Otherwise, in other classes and courses, this was not done. So what happens is you can square both sides, correct? So the d minus 12. So this idea should be good enough. I can leave it from here, no? How can a big quantity, a smaller quantity will be equal to bigger quantity plus some more? Not possible. Don't do it. And if you do it, you will get a nice answer. And that answer is very famous, well known. And they do this analysis. That answer is well known. And they think they've done the problem. They've solved the problem. Solution of the problem is if you put that value, it should satisfy. So what will happen is in this case, there will be contradicting declarations. If you complete this, I'm not going to complete it. Answer you have to find at home. Okay? Then we will read next. Okay, so this equation doesn't have a solution, and if you if you solve by happy-packy algebra, you get the right answer. But if it is descriptive type exam, you will get a big zero. Okay? Because what will happen is you will have to assume something like this. Somewhere you will have to assume, on the way you will have to assume this. Now how can they be true? It says sometimes you will say t is greater than 32, then later on you will say t is less than 20. That will be another warning sign that stop. Yeah. You will say loudly. Yeah. No. This is what I am here. I will tell you also. Don't worry. So this, okay, so now I'm leaving this problem for curious minds. This is wrong. On the way, you keep declaring things, and you will see there are contradicting declarations. Don't proceed. And if you proceed blindly, you will get some answer which may or may not be right. By chance, that answer will be right. But this approach is wrong. From the beginning only, this approach is wrong. Now, what is the correct approach? I hope I'm conveying my point. Maybe some problem you can solve by algebra, by graphs, you're right. But you will be embarrassed. You will be embarrassed by your colleagues, by your juniors, by your seniors. What? You solved this problem? What is this? You declared this and that. How do you proceed? Don't proceed. The moment you get a contradiction, don't proceed. If you proceed, you may get the right answer by chance. But you will be embarrassed. So this actually geometrically this is not a correct approach. The correct approach should be yeah, so what yeah you can say this. Answer of this. Ah, so what you are getting? So what you will be taking is positive, na? And you are getting P negative. So what I am saying is, if you are not doing it methodically, if you are not leaving out the problem at the right time, later on you will get a lot of funny things. Okay? So now you do it later. Okay, now see, this is the correct approach perhaps. Yeah, it happens to be this thing, na? Equilateral triangle. So what? You can say this. This is x, this is x, this is x. So this is the what? Correct? And what will this be? X square minus 16. And this will be what? X square minus 36. So this will be correct? So this will be T or say R, and this will be R minus 12 plus, sorry, X R minus. Can this have real roots? Can this have roots? The biggest number is equal to two smaller numbers. Yeah, there is a good chance this will have some roots. And if you solve this, you will get you declare proper declarations. Now then the question will be how many roots? So declare. Take a pledge today that when you square an equation, you will check both the sides are positive or not. If not, declare. If you can't declare, you leave it. You can't declare, you leave it. Correct? So suppose you have this. Solve this equation. No, you square it, no? It will get a solution. Here it is very transparent.
The minus 5.
Here it is very transparent, no?
So actually minus 5. X is equal to minus 5.
So x equal to minus 5. So what? 4 minus 3. X is equal to no. X equal to 1. You square both sides. Minus 1. Minus. So what I am telling you is don't square this, leave it. Say no solution. Because a positive quantity cannot be equal to a negative quantity. Leave it, don't do it. Say no solution. And if you do, you get some solution. And you'll be embarrassed in the end, or you will not get the correct marks. Okay? So some poor students may say that, yeah, this x equal to minus 1 if I put. And plus 4 is square root of 4 is plus minus 2. It's wrong. It's a misconception. The square root of 4 is 4, so 2. It's not plus minus 2. Okay? So, if you face this equation, it's a very simple equation. I mean, want to solve this, you cannot square. You are pledged. Taking a pledge. That you cannot square negative. And here you can't declare also. No? Minus 2 is minus 2. So you cannot square, so there is no root. This doesn't have any solution. Okay? Here it's not very transparent. Pardon? Yeah, okay, so let me tell you. So, square root of 4. See, there are two things. How this plus minus thing comes, and when it comes, we are very excited. I remember when this plus minus notation was told to me. I thought I learned a great thing, plus minus. But please understand how this plus minus arises. Yeah, what's the question? Pardon? So it's by analytic.
An angle chasing theorem.
Yeah, good. Yeah, you should open all your ears and mind open to check whether the problem at hand is solvable. I mean, whether it has a practical solution or not. Don't waste your time. Correct? Yeah. And then uncertainty. No, but my topic is algebra. So I will tell you things through algebra. Okay? Now what I am leaving it out to solve this equation and do the proper declaration, you will find all the declarations are helping you to reach the answer. Correct? To this. And that will be the correct solution. And interestingly, what happens is, here also, if you ignore all the theory, everything, forcibly you will get the same answer, it seems. But that will be wrong. Okay? So yeah, listen. So when x square is equal to 4, so what are the roots? So what we do? This means x equal plus 2 or minus 2, correct? This is where plus minus comes. One more place where plus minus comes will come is x is equal to 4 to the power half. And this means it has got two branches, plus minus root 2. But square root 4. And then it is plus minus. Square root of 4 is 2. It's not plus minus 2. If you think so, it will go wrong. Okay? So here, roots of this equation are 2. Roots of this equation are 2. But this root 4 is 2. It's not plus minus 2. Okay? So, curious minds will solve both these problems and get to the point which I want to get, because time is not much to solve. But this solution is quite popular in websites, which is wrong. Yeah, square root of 4 is 2. No, it is no y. It is a convention. Everything cannot be. Yeah, so this root 4 is plus 2. But square, x square equal to 4 is plus minus root 4. And root 4 is 2. Correct? That is why, when you solve this problem, solve this problem. X equal to?
ये तो करा था मेरी आगे जस्ट दिया
You have to find the real root, yeah.
जस्ट given
Minus 2.
So first thing is, here also you should do one declaration that d minus x should be positive, because you are taking square root of that. Some declarations, they may not matter, but you do them. So what it means is x is X is what? Less than. And this. Okay, yes. Yeah, this is correct. Correct? Why is correct? Because. Now if I say this, yes. It's correct. No. This is correct. This is what we know. What it should be. Correct? So this. So let me again tell you, it's a very big rule in algebra. If you want to square an equation or any equation, both the sides must be positive. If not, you declare, and if you can't declare, don't square. Don't square. Leave it. Correct? So this. Now we'll do some more things about it. Now let us see one more thing. So find out the root of this. So many times in your problem there is a parameter k. So the parameter k is this. What is parameter? Parameter is something which is used by which is indicated by a letter. It can be fixed or it can be varied. But constants are constant. 5 is a constant. 5 cannot be varied. So k is a parameter. So find out the root of this equation. So what is it? X is equal to what? 3 by k minus. Yeah, okay, so this will be what? 3 plus x upon x is a. So this is what? 1 plus 3 upon x is a. So 3 upon x is what? K minus 1. Correct? So this will be x will be what? K minus 1 by 3. Is this correct?
Sir, 3 by k minus.
K is not equal to
3 by k
बच्चा
oh, what is it? Yeah, then 3 by yeah. 3 by k minus 1 is correct?
yes
Okay, tell me what is the solution?
अरे यार
X is equal to what? 1 by k minus 3 by k minus
one
and k is not equal to
नहीं जीरो नहीं
12. In your solution, in your analysis, you avoid division by 0. Don't let it come. So, it is examiner's duty to say k is not equal to 0. And if examiner has not said, then it is your duty. So this. Is this assumption is correct? Now what is it? No, x equal to what is the expression? This expression is correct. So now there is a fear that division by 0 will occur when k is equal to 1. And infinity is never an answer of any question. What is the length of this table to say infinity? Or say between minus infinity and plus infinity. So infinity. So information should be real, finite, and it should also be unique. Yeah? It should also be unique. So the rule is whatever answer you are looking for, it should be real, finite, and if possible unique. If it is not unique, there should be some ground on which one solution should be discarded or something. Because you know this Ola Uber is there. So Uber, when you book, so it tells you this will be the fare. Ola, if you book, the say fare will be 450 to 500. And now 450 to 500 means you bargain with the auto fellows. So the auto has come to your home from a distance. It's not good to bargain. You're called. And when you get down, you ask him what is the fare, he will say 500. He always says the higher one. Says 500. So there is a scope of this thing, disagreement. It says 450 to 500. Why should I pay 500? And he will say, why should I pay 450? So in science, in economics, in finance, in commerce, these double things are not allowed. They are not welcome. There should be some criterion by which you should be able to discard. Suppose you're solving some problem, number of terms in a sequence, so n is equal to 5 or minus 3. So you ignore minus 3, na? Because there is nothing like minus 3 terms. Correct? So your answer should be so this really this is your business, your responsibility. Correct? Let us solve one problem. Yeah. Find the complete solution of this. So you can need to get the answer, yeah. So what is the solution? X equal to k plus 3 upon 2. Yeah. X is not equal to say something else. You are right. You have written the answer in terms of the parameter k. Your answer should be in terms of parameter k. K is not equal to minus 1 and what is the other value? Is there not equal to x is not the value. Yeah, 3. X is not equal to 3 is okay? So basically, when you solve this problem, first thing is the declaration. Today's topic is this, declare. If you want to solve the problem successfully, declare. So what will you declare? Correct? And then it is ordinary algebra, usually. To do that and come back to the declaration. So this should not k plus 3 upon 2 should not be equal to what? 1. So k plus 3 should not be equal to 2. So k plus 3 should not be equal to and what? This. So k plus 3 upon 2 should not be equal to k plus 3 should not be equal to 2k. Is this correct? Minus 3 or? Correct? This, and this. They are the complete answer. If you don't write other two, the answer is not complete. And don't tell examiner that x should not be equal to k to find out. To find out that what are the coefficient values of k? Correct? This. This is the complete answer. And this is IIT only in the country we bothered about these points. Otherwise, board exams, etc. Yeah, x is equal to k plus 3 by 2 decimal. And go back and see the answer there. But now it is not this. You have to prevent your answer from becoming infinity. You have to prevent division by 0 in your calculation to declare. Okay? Next. So be careful. Yeah, next do this one. X plus plus 2. Solve this equation. Yeah, solve this equation.
The roots.
So what x plus 2, x minus 3, and 2 minus x, and 2 plus x. Correct? So we get very excited and solve this and say about x is equal to 5 by 2. Is this correct? Yeah? So don't do this, don't get excited. So many times you don't get excited and then say, forget about it. Don't get. Better thing is to bring it here. Correct? Then you will not miss anything. So x is equal to minus 2 or x is equal to 5 by. And one important thing is this, you cannot cancel a factor from both the sides of the equation if it is 0. If it is 0. So when you are cancelling this, theoretically if you say x is not equal to minus 2, then it is allowed. And when you put this x is not equal to minus 2, that means you have solved only half of the problem. If x is equal to minus 2, if x is not equal to minus 2, or x is not equal to minus 2, you have solved. Then you solve x equal to minus 2. And it's very simple, it satisfies. So this also is. So please remember, up and down. This thing and this thing, they are different. This is not equal to this. This is not equal to this when x is equal to, x is not equal to, this is equal to, sorry, this is equal to this when x is not equal to 1, when x is equal to 1, then what? So this is true only when x is not equal to 1. That means what? You cannot cancel factors. And if you cancel, then you have to do this. X is not equal to 1. So you cannot cancel a factor from up and down, which is 0. Otherwise what? And you cannot multiply by any equation by a factor which is 0. Otherwise you have given some equation this equal to that, to multiply both sides by 0. Equation is not there. So the multiplication of an equation by 0 on both sides is not allowed. By a factor is not allowed if it is 0. Similarly, cancellation of a factor up and down is not allowed if it is 0. Yeah. This one is okay, na? I mean, this we have brought it here. Na? We have brought it here na? And taken this common x plus 2. Okay. Yeah, do this rather than this cancelling the factor. Once in RMO, an equation in the equation was asked, it had 6 equations. And a lot of factors were getting cancelled. So our students got them and finally they got 2 answers. Those who were clever, they were wondering where are the other answers they could search. But the idea is to bring everything in one side and finally you decide what are the rules. Don't cancel. Okay? Next. Next, let us solve this equation. Find all roots of this equation. Yeah. X equal to 6 is the root. Then 11 also. 11 is the root. So 11 is not a root. Yeah? 6 is the root. But poor students may argue like this. They may say 11 if you put here, and this, so this is 9, and this is plus minus 15. So it's okay. They will say that. They will say you say plus minus. So this take minus sign. No, there's no plus minus thing. If it is plus here, so it is. So basically, what how you will solve this problem correctly? You say x minus, and you always want real roots, and 8 minus x should be positive. So you say x should be less than 8. And now you can square both the sides because you have declared this square both sides. So all of you will get x equal to 6 and 11. 6 will satisfy yes, 11 will not satisfy. And on this I have argument with old people who were scientists, who were mathematicians, Zafar or engineers. They told their ward that the roots are 6 and 11. And the ward was saying, no, no, root is 6 only. So then they said, you are reading out wrong things. So the case came to cases and they used to come to me, then I tell them, can you tell me an equation whose similar equation slightly changed, whose root will be 11? X minus this root will be what? But not that one. Correct? So be careful. So when you are asked equation, they may have less number of equations, you may get more, or you may have more number of equations, you will get less. Correct? Okay, so this. Yes, solve one more. Find all roots of this equation. Find all roots of this equation. Hmm? Hmm? Yeah? No solution. No. Serious looking equation. No solution. Yes. This has no solution. Why? Because for squaring you will say this number. And when you square this will be what? So you get what? 13x is equal to 65. X is equal to what? 5. But the declaration says what? X should be less than? No. It's not a solution. The poor students will say, no, 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 go and put it 5 here. So this will be root 1 and this is minus 1. Yeah, root 1 is plus minus 1. No, root 1 is not plus minus 1. Okay? So this serious between equation doesn't have any. Okay? So this. Okay, now next. Next, what we will do is this that, yeah, this mod x. So this absolute value function, this only IGA only in the country emphasized the use of this in problems and all. Okay? So mod of x, what is it? This is a two-piece function, this is x. When x is positive, this is minus x. When x is, you can put equal to both places or one place. Okay? It's a two-piece function, it's a conditional function. Poor student they think x mod x is plus minus x. It's wrong. In plus x, it is a local function. Plus x, it depends where you are. If you are in the positive side, it is x. If you are in the negative side, it is minus x. Correct? So this. So and if you plot both of you coordinate between this y equal to x, this line, and this y equal to minus x, this line. Is this okay or something should be done?
Sir, darken. We should darken the positive.
Yeah, so this piece will be for positive values of x, this will be, so it will be this p-like function. And 0 is called what? 0 is called node. So this side the function is x, this side the function is minus x. So whenever this mod sign comes into your equation, you have to rewrite the equations. First you declare x is positive, then you declare x is negative. Okay? So let us find out roots of this equation. Yeah, let us find all roots of this equation. Yeah, any question?
The 3 and 2.
No solution. No
I
solution. No solution. Why? So he says no solution. Check. Mind, huh? Yeah, so the procedure should be what? Your procedure should be good enough. So what you should say, yeah, so your procedure should be this. Declare, tell yourself, you pledge that you will declare things. So what you say when case number one, case one is what when x is positive. When x is positive, this will be written as what? The roots will be what? No. When you declare x positive, hello. When you declare x positive, you are getting roots are negative, no solution. Correct? And then when you declare x negative, so then this will be minus 5x. So when you are saying this, no. Hello. When you are declaring what? X to be negative, your roots are 2 and 3. Positive, it's not correct. That is, this equation doesn't have roots. Correct? Now next question. How many roots this equation has? How many roots? 4. So the quadratic equation has got 4 roots. So when mod function or absolute value function comes, the equation loses its characteristic. It may have, the quadratic equation may have 2 roots or may have no roots, or it may have 4 roots. Correct? What about this? How many roots this equation will have? What are they? X is equal to, so when x is positive, it is x square minus x minus 6. So what are the roots? X equal to 3 comma minus 2 now. So 3 will be taken yes because it means the declaration. Means the declaration. Correct? And when the x is less than this, then what answer will be there? Minus 3. So whenever mod function mod x comes in your equation, you will rewrite the equation 2 times. When x is positive, then when x is negative. Correct? Now this node may not be 0, so node is what? Okay? So this. So now tell me this, suppose somewhere it is written 4 minus 3. What are 4 minus 3? What do you write?
1.
This everybody. But something else. Yeah?
Minus whole into minus 3.
Say that. You should say, oh, I'm sorry, this, not this. Oh, very bad. This.
Mod 4 minus 3.
So what will you say?
Mod 4 minus 3.
This is equal to? You should say this is equal to 4 minus 3. So your intention should be to remove mod sign and then you get something. When some equation with a mod sign has come, you try to remove it. So how will you remove when the inside thing is positive? It is positive. Correct? Of course, this is equal to 1. So what happens is this 4 minus 3 is very important. Otherwise, students know it like this. 4 minus 3, ignore the minus sign. Ignore the minus sign. We are not working on a slate that we will have it. You have to write it properly. So that means what? This is equal to what? X minus 3 when? This is a two-piece function. When x is greater than or equal to 3. And this is equal to minus times x minus 3 when x is. So this. Correct? So this is y equal to x minus 3 line. Correct? And this will be what? Y equal to minus x minus 3. So y plus x plus y equal to. So yeah, so what is it? This line. So x minus 3 is basically this. Correct? And this will be plus. So this will be x plus y equal to 3. This line will be x plus y equal to 3 like this. And this is the node. But this piece is valid for x greater than 3. So, and this piece will be valid for x. So they will be removed and it will be again p-like function at the node. So what is the node? 3. So when you are on the right hand side of this, it is x minus 3. When you are here, it is minus times the two-piece function. So wherever this comes, you will have to calculate where you are, where x greater than 3 or x less than 3. And the node is what? What is the node of this? This mod function. What is the node of this? Minus 4? Yeah, so value of x where this becomes 0. So this is x equal to what is the node? Minus 4 by 3. Correct? So now suppose you want to solve this problem. So what are the solutions? First you declare x is greater than 3 and then rewrite it, say. Then you declare x is less than 3, rewrite it. 4 and? So the correct method is this. The simple can guess and tell, but correct one. If x minus 3 is positive, this is x equal to 10.
10.
Is this correct? Yes.
Yes.
Now we say second case. X minus 3 is negative. So this will be minus times x minus 3 is equal to 7. So this is minus x plus 3 equal to 7. So minus x is equal to 4. So this will be x equal to minus 4 is correct? Yeah. Minus 4, right? What will be the solution of this? No solution. Very good. So positive quantity can never be negative. No solution. And if you do that, you will get in case 1, case 2, you will get no solution. There are contradictions here. Okay? So whenever mod sign comes, you will have to rewrite it. Whenever mod sign comes in an equation, you have to rewrite it. Correct? So how will you do this? You find the root of this. How many roots you can get?
7.
So first you get the x is greater than 3, rewrite the equation, get the root, check whether it satisfies. X equal to 19 by 6.
Yes.
Only one root or two roots? 19 by 6. Do you agree? Okay, so will there be another root? X equal to 6. 13 by
19 by 8.
19 by 8. These two solutions. Minus 19 by 23 by. Which one is wrong? Which one is wrong out of them?
23 by 8.
10 is the right answer. Yeah. 23 by 8 plus 19 by 6. And what is the other one?
19 by 6.
19 by 6. Are they correct? Why are so many answers? Okay. So first case, when x is greater than 2, this will be x minus 2 to 7x and minus 21. Correct? So this will be what? So 7x to 6x minus 2 and plus 21. So this will be what? 19 by 6. Now you say what? You see, you have to see this 19 by 6 is greater than 2. Yes. Second case, when x is less than 2. So then this will be 2 minus x equal to 7x minus 21. So this will be what? So minus 8x equal to minus 21 minus 2. Minus 8x equal to, so x is equal to 23 by 8. Is it less than 2?
No, sir. No, sir.
Yeah, but this, yeah, so this, will this be a solution? Yeah, no. They're very dicey. You have to, when you get the answer, you have to check this thing, what we call it? The declaration. If they match the declaration, okay. Right? So this is how we are done. Okay, so this we will solve other more problems and they are done like this, okay? Yeah, you can do this x minus 3 What are the solutions? Yeah, x is greater than or equal to 3. So all numbers greater than or equal to 3. So what you will say case 1.
सेम हो जाएगा.
So this is case minus. Yes. And if you say this will be minus x minus 3 and x minus 3. So this will be what? So this will be minus x plus 3 and x minus 3. So this is 2x minus 6 minus 2x minus so x is equal to what? 3. Which has been included here. No, which has been included here. So that means the net answer is x is greater than or equal to 3. Correct? Okay, so now let us do this x. Let us find all solutions of this. So when your absolute value function question is there, find out the nodes. So three regions, if there are two nodes, three regions will be created. And you go region by region first. X is less than 1. So you will not include 1 here and this. That is from here to here. Now rewrite this equation. So one small thing will help you here. What? If you want to rewrite this equation and in this domain, so where are you? Suppose you take a critical number 0. If you put 0 here, this is negative, na? So you have to supply a minus sign. And if you put this 0 here, typical number in this domain, so 0, so this is negative, so you will have to supply a. So what is the answer here for this? Yeah, so what is the answer? X minus, so minus x plus 1 minus x plus 4.
Sir, minus x can't
Oh, sorry, minus 2x, they will not cancel. Minus 2x is equal to 3 minus 5, so minus 2x is equal to minus 2, so x is equal to 1, correct? But x equal to 1 we have not included. You may include x equal to 1 here and say yes, it is a solution, or you may include it next step. Correct? Pardon? Wait. So that means what? This simple equation has got infinitely many solutions. How? When you come to this domain, yeah, when you come to this domain, what? 1 to 4. Actually, the practice is this: you include 1 here and don't include 4. And if you want to rewrite, that is you have come here. Take a typical number, say 3. If you put 3 here, so 3 minus 1 is positive, so this will be written as it is. Now if you put 3 here, this is minus of negative, so you will have to supply a minus sign. So x cancels, so this is what? Okay. Yeah, please go.
Four students are going to take. D.
So this, so 3 sometimes what happens is x disappears from your analysis. X, x disappears from your analysis. What it means? It means that this whole thing is a solution. Okay? Yeah, Yeah, so this means what? This declaration is the solution. Declaration is the solution. So, and when 3 is equal to 4, then that means whole declaration is not the solution. Correct? So this is the solution. Now next region you will go is what? In principle, in very good problems, you don't include the left one. You include it here. So when you include it here, so what will happen? You put a difficult number, say 5. So 5 minus 1, this is positive. So this will be written as. This is x minus 2. Yeah. If you put 5, this is positive. So you will get x is equal to yes. So ultimately, all the solutions are, whenever there are cases, solutions are union of all. Union of all. So that means what? That's total solution is this. So in your exam, you can write it like this, and you can write it like this. Correct? Now tell me whether pi is a solution. X equal to pi. Pi. Capital is pi. X equal to pi is a solution. Solution. X equal to root 17 is a solution.
Yes.
No, it will go outside. Root 15.
Yes.
Root 8.
Yes.
So this simple equation, you will be asked when you have to do. Write a simple equation. Algebra equation which has got hello, which has got infinitely many roots. So this is one equation. So what are the solutions? All numbers from 1 to 4. Correct? Yeah. Next, we will be solving more interesting problems on this mod functions or this absolute value function. Correct? So now let us come to inequations. Correct? So inequations are like equations. So suppose you have this x plus y is greater than or equal to a plus b. So you can say x is greater than a plus b minus y. So if you transfer something which is added on left side, right hand side, it will be subtracted. Hello, it will be subtracted, and vice versa. So whatever is subtracted here will be changed side. It is added. Correct. But what is important is, yeah, do one thing. Why don't you come here? Yeah. I've got a special seat for you. Chairman. I was having this idea. Thank you, you pointed it out. Yeah. Okay, so this. But what happens is if kx is equal to kx is greater than y. So x will be greater than y upon k when when k is positive. And this will mean x is less than y upon k when k is negative. This creates all the problems. And inequations are very dicey things. I feel nervous when I solve inequations. Correct? Because of this, if you multiply an inequation, multiply and divide by a negative number, sign of the equation changes. If you multiply an inequation, multiply or divide an inequation by positive number, it doesn't change. Correct? So this. So another interesting thing about inequations is two inequations, if they are the same direction, you can always add them. You can always add them and you will be right. You can never subtract two inequations. Why? because subtraction is non-commutative, na? So suppose this 5 is greater than 3, 2 is greater than 1, you can add them, you will always be right. If they are same value, you will always be right. And if you subtract them, the question is you will subtract this from this or this from this. Ambiguous. You will get both the things. Take whatever satisfies you, and it is wrong. It is arbitrary. So you cannot subtract two equations because subtraction is, if you subtract them, so this is what? This is 3 is greater than 2, okay? Now this will be what? If you say, so minus 3 is greater than minus, one of them is wrong, one of them is right. So you should never subtract two equations, howsoever desperate you are. Sometimes in international Olympiads and other Olympiads, question will be asked, and the proof will be you write two equations, subtract them, it will come. But if you do it by this route, they may be true otherwise. But if you say directly subtract them, it will be wrong. Because subtraction is not commutative. Addition is commutative. Correct? So you can always add two inequalities. You cannot subtract two inequalities. Never. Never. And what? Suppose this minus 5 is less than minus 3 minus 2. You add them, so minus 7 is less than. Correct? So you cannot subtract them. Subtraction is bogus, it's ambiguous, it is not allowed. Okay? It's wrong. And multiplication, if you multiply this and this, so this what? 10 is less than 3. 10 is less than 3. So you can multiply two equations only if all sides are positive. Then you can't multiply those. Correct? You can multiply two equations if all sides are positive. If you want to multiply, then you have to change. And this 3 you have brought here and 5. And what? This 1 you have brought here. Now you can multiply. So you can multiply only if all sides are positive. Okay? They are very serious rules, and just because of this, solving an equation becomes difficult. So let us do this. Yeah. So one thing we can do is this, we can bring it here, so this 5x, and then this will be 7 plus 2. So x is greater than what? 9 upon 5. Pictorially what we say is 9. Correct? Is there any other way? Can you do this some other slightly? So this you have brought this here, now you can take that then. So minus 2, so this will be what? Minus 5x, and this will be what? Plus 9. Then you bring this here, so minus 2, minus 5x, and minus 9. No, sorry, minus 7. Yeah, this was 7. So this will be minus 7, so minus 9. Now divide by minus 5. The moment you divide by minus 5, this sign will change. So again you will get the same answer. Correct? So this be sure, be clear that if you divide or multiply by a negative number, sign of equation changes. Correct? So this. Now let us solve some problems. Yeah, one interesting thing. Suppose 2 upon 3 is okay? 2 upon 3 is greater than, oh, 2 upon 3 is less than 3 by 2. This will be what? Greater than. Correct? So this statement is correct? Now let us do this. Now this minus sign, some students may think minus sign will take here. And this minus sign will take here. So cross multiply this will be what? 8 is greater than 9. Okay? Somebody will say, no, actually these minus signs are up. We should consider like this. So this will be minus 8 is greater than minus 9. It's correct. Somebody will say, no, we will take this 2 is minus 3 here and this what minus 3 here is. So this is 8. Somebody else will say, no, we should take both of them here. Minus 8, and this will be what? Minus 9. 4 statements are there, come, and they are contradicted. So what is the moral of the story? What do we do? Because what happens is, in primary classes, if you have to prove that this is, we used to do 2-3 methods. We used to equate numerators, correct? And we used to equate denominators with their. We used to cross multiply this. Habit has come from there only. This 8. Sorry, suppose we have to prove this. So what 8 is less than 9? We used to do this one. When decimal numbers were taught, we used to find the decimal values. But one thing we were not doing that time. Yeah.
In cross multiplication, either both denominators.
No. You don't have to make new rules. Yeah, in mathematics you can make when this is there, it is like this, This some medicine to kill cockroach. You catch the cockroach and then put drop of the medicine in the mouth of cockroach. Is it a way? No. So in mathematics, rules are made which are always valid and simple rules. So here the rule is, so we were never doing, while checking this, we were never doing this. So the moral of the story is, now onwards we will be bringing everything in one side and then decide. So there in those classes we could have done this. 8 minus 9 upon 4 is yes, is correct. And it will be this. Just do this. Don't make rules. No rules. Bring everything in one side and have 0 this side. Then it will be right. And this is the bottom line in solving inequations. Some inequations are there. Cross multiplication, if possible, to avoid. Bring everything in one side and simplify then. Correct? So let us solve some problem. Yes, and then you can make rules about subtraction. When this happens, then you can subtract. Don't one rule method. Two inequations, they are the same that you can never subtract. You can never divide. Correct? Because division and subtraction, they are ambiguous, na? You are in which by which. But you can always add them and you can multiply two inequations when they are all sides are positive. When all sides are positive. Correct? So this. So the rules are like this. So suppose we want to solve this problem. Okay? So the thing is to bring everything in one side. Don't cross multiply. Okay? So this. So we bring say this. So this is 6x. Correct? Also this will be 6 and 6. Yeah, so 6. Yeah, 6. So this and this cancel, so then 2y. So this you can forget. Yeah, having 0 there is a great thing. Everything you can transfer everything there. Okay. So what? This means what?
Z will be 6x minus
This means 3x minus 4 is greater than
6x minus 9.
0. Yeah, if inverse of something is greater than 0, then that thing itself will be greater than 0. So x is greater than what? X is greater than 4 by 3.
6x minus 9.
This is the best thing you can do.
It is 6x minus 9.
6 also. 6x minus
9.
oh, sorry. Yeah, 9. So this will be oh, this will change the whole thing. This will be minus 1. Huh? Thank you. So, so now you minus sign if you take, if you cancel this sign will change. Yeah. So then this. So x, yeah, it will change the whole answer. So 4 by 3. Right? Yeah. 4 by 3. So what? Bring everything in one side and then you can do something. There are other methods also as well. Now other method is what? Other method is to say you want to cross multiply this now. So this. So let now you can cross multiply. So this will be what? 6x minus 9 and this will be 6x minus 8. Is this true or false? Minus false. If it is false, that means converse of this will be true. Reverse of this will be true. So 3x is less than 4. So x is less than 4 by 3. Correct? You will get it like this here. This is called careful cross multiplication. This is called careful cross multiplication. So what you have done is, this quantity was indefinite. So you wanted to multiply your equation with that. So you have declared it positive. And then you see what happens. Okay? Then you got a false statement. So when you get a false statement under a declaration, that means the reverse of the declaration is complementary of the declaration is that. So that is the solution. Correct? So now let us see this. Let us solve this equation. Okay? So one method is careful cross multiplication. That means you will like to cross multiply them, but this is indefinite now. So you declare this. So this will be correct. You declare this, so this you have declared it positive, so this. So this is 14. So this is what? Till x is less than 7 by 2. So the answer is not this. The answer is this and this. So what will you do? Put both of them here. X is less than 7 by 2. Any mistake you can tell it. Okay? And x is greater than 3. The overlap between the solution. This is called careful cross multiplication. Okay? So what you did, you want. And poor students are not afraid of it. They are what is this, so they just want it. They didn't get this answer. Correct? But they will not get the good answer. Okay? So now what? You declared the second thing. What? This is negative. If you declare this negative, this sign will change. Huh? So actually this sign will change this sign. So this will be 7 by 2 and this sign. Correct? So now if you do this, x is greater than 7 by 2. And what is this? X is less than 3. What is the overlap? They should get a different height. Correct? What is the overlap between them? None. Nothing. 5. So the total answer has come here. So your answer is x is less than 7 by 2 and greater than 3. No, greater than 3. Okay? Now you should also put some number here, say 3.1, We put 3.1, what will this be? 2 upon 0.1, this 20 is greater than 2, yes. And if you put a number outside this, it will not be satisfied. It will not be satisfied. Correct? So this is called careful multiplication. Okay? Careful cross multiplication. Let us see one more problem. Yeah. 3 upon x minus 4 is less than 5. Let us solve this. So what we will do, we will have to multiply by x minus 4. No? So we say first case, x minus 4 is positive. So multiply by that, so this will be 5x minus 20. Correct? So there will be 5x 23. So x will be greater than 23 by 5. Is this correct? So your answer will be this. You will have to put both. X is less than 23 by 5. Correct? So x is greater than this, so this. And it says x is greater than 4. So this 4 will be here or here? 4 will be this side, no? So what it says, x is greater than 4. So the answer is this. So what is the answer? X is greater than 23 by 5. Correct? Now there are two cases. What will be the case 2? Case 2 will be when this is negative. Case 2, when x minus 4 is negative. So when it is negative, this is negative. When you multiply this sign will change, so ultimately this sign will change. Okay.
Yes.
So this, correct? X is less than 20, so this. Now if you put this and this, so what will happen? X is less than 4 and x is greater than 23 by sorry. X is less than 4 and x is less than, yeah, x is less than 4 and x is less than 23 by 4. This. So where is the overlap? So it says x is less than 23 by and x. No, here. We have got this. We have got this answer. X is greater than 23 by 5. Now let us see this. Here if we multiply by, if we say this is negative, so finally this sign will change. Huh? So this sign will be 23 upon 5 greater than. Now if we put this, yeah, x is less than 4 and x is greater than, x is less than 4 and x is less than 23 by this and this. So what is it? This overlap is x is less than, no, that's a mistake. Hmm. Yeah, x, yeah, this goes, x, so yeah, that's okay. X is less than 4. So x is less than 4 is this, correct? And now this sign will change. So x will be less than 23 by, so this x is less than, oh sorry, x is, yeah, see x, see this, you understand this. When you say x minus 4 is negative and cross multiply, so this will be 3 and greater than 5x minus, so this will be what? Greater than 5x minus 20. So this will be, so here what you will have? So this, yeah. So 5x minus 20. So this 5x and this 23. So x is less than 23 by 5, correct? So x is less than 23 by 5, yeah, this. Correct? Now if you take the overlap, so what is it?
Solution.
So some problem. Yeah, what is the problem? Uh, yeah, first what we have done is this 3 and then multiply by 4. So this. So 23, so x is greater than 23. by 5 is this. Oh, 23. Oh, this is the mistake. So this is. Yeah. 20, if we place them properly, so this is 23 by 4 and this will be 4. Na? So x is greater than 23 by 4 and it says x is greater than, yeah, so this answer will be x is greater than 4, sorry. And this will be 23 by, other answer will be what? X is less than 23 by 5. This. Yes. Now let us do this. So if it is negative, we multiply it, so what will happen? This will be 3 and 5 as it is. So finally, what? X is less than 5 you see, 5. Oh, yeah, 5. Then only 23 by 5, yeah. Oh, yeah, it is greater than yes, yes. So 23 by 4, so this will be 4 and this will be 23 by 4, 5. Now.
Yes, sir.
So then what? We will say this is less than and this is greater than.
Sir, x is greater than 23.
Yeah, now it's so 4 to 23 by 5. Is this correct?
Yes.
This answer is correct? Check. Yeah, suppose you put 4.1. So what do you get? So 3, 4.1 is the 0.1. Stay. So x is greater than 23 by 5, correct? And x is greater than 4. No, sorry. Yeah, I'm very sorry for this. So yeah, let me tell you. So what will happen is this is 4 and this is 23 by 5. So x is greater than 4 and x is greater than, yeah. So this is the overlap. X is greater than 23 by 5. Okay? Now come here. Yeah, now come here. So what will happen in the second case, x minus 4 is negative. So when you multiply this, so this sign will change. So 5x minus 20. So this will be 23 upon 5. X is less than 23 by 5. So what? 23 by 5. And this is 4. So x is less than 23 by 5 and x is less than 4. So what is the overlap? 23 by 5
Is more than.
oh yeah, it is this here. This is 4 and 23 by 5. So what will happen here? Sorry, I'm very sorry for this. So x is less than 4 and what? X is less than this. So this will be x is less than 4. So what is the answer? The answer will be x is less than 4, comma what? Or
X is greater than
x is greater than 23
23
by
by 5.
5. Yeah, this does. Or you can write minus infinity to 4 union 23 by 5 to infinity. There are two ways you can write it. Okay, yeah. There are two ways you can write the answer and you such question will be there in the test. Okay? So this. Yeah, we have a break and then after the break we meet and discuss more things. Yeah, sorry this. I know the numbers were very close by.